So traditionally, space exploration has been you build a multi-million-pound rocket, you put a person or a multi-million-pound satellite in it, and then you spend millions of pounds sending it up into space. As the technologies got cheaper, companies have started looking into commercial space tourism. And personal space exploration is about taking this one step further for unmanned space exploration to make it possible for the general public and universities to participate. So generally speaking, a project will be set up by an individual or a group, and that project organizes the manufacturing and the launching of the spacecraft. Most of the projects are open source, and they're also crowdfunded. So generally, people will donate to the project, and they'll either get to share a spacecraft, or they'll get their own individual spacecraft. Typically, the term open source is used for software, but here it means that anyone can get involved. So all the hardware designs are available for everyone, and anyone can contribute to them and change them to improve the project. So the spacecraft that gets sent up, this is a CubeSat, and it comes in 1U and 3U variations. Typically, 2/3 of a 3U craft will contain its propulsion system, and the other third will contain lots of smaller craft, but sometimes it can contain other equipment as well. This is a ChipSat. It's a tiny single chip craft, and both these and the CubeSats are built with off-the-shelf electronics. That means that anyone can go and construct their own and do it really cheaply as well. Typically, you can fit hundreds of ChipSats into one single CubeSat. This is a thin film craft. These are amazing. These are a few microns thick, so they're much thinner than paper. This means you can stack thousands of them into one single CubeSat. Another cool thing about the thin film craft is the frame that keeps its structure. So it just consists of a metal loop, which, as well as holding its structure, also acts as the antenna, so you don't need any extra equipment for the radio communication, which keeps it really light. So all of these spacecraft are really small, and this is because then the spacecraft can be launched into space cheaply or for even free with projects like the NASA Enlala program, which is where NASA will have spare space on their spacecraft, and you'll put a CubeSat in it and send it up with that spacecraft. There's also My Ground Stations, which is a project of satellite dishes that anyone can access. And these will collect data from the spacecraft and then send it to the CubeSat project so that they can analyze it. And that's what I was doing last year. So last year I created a mobile application, and here you can see a picture of the augmented reality, which let you put your phone up into the sky, and then it would point to where your spacecraft is. So what's the point of all this? For many, it's just the fun factor. This kind of stuff is just really cool. It's really awesome. So this picture was taken with an Arduino sat, which is where the project will give you a CubeSat, and you get to program it yourself, and then they will send it up into space for you. Sometimes it's not just for the fun factor, though. There can be some really serious science behind it. So on the next slide, there's KickSat. And this is an open ChipSat project run by a student from Cornell University. And they were trying to detect patterns in cosmic space dust that moves at hundreds of miles an hour to see whether or not they could harness that energy and use it. Two more similar projects came out of Cornell University. One of them was going into low Earth orbit, and the other one was going all the way to Saturn. These were just after a year, and you can see that the ChipSats get much smaller just in that short space of time. This is LightSail 1. It's kind of in a similar vein, but they're using solar wind, so they project their CubeSat towards the sun, they open up the sail, and then the solar winds will shoot the spacecraft back out really quickly, and they reckon they can get to the next star system in about 100 years. This is RAX-2. They were trying to understand the physics behind plasma anomalies in space that cause communication issues with spacecraft. Rather ironically, both its radios went down in April, and it's still lost in space. This is an awesome project. This is called QuakeSat, and they were trying to detect earthquakes from space by measuring the electromagnetic activity that's released by earthquakes, and then they were detecting it from space. This is ExoplanetSat. So what this does is it stares at a star, and it looks at tiny variations in the brightness to try and determine whether or not a planet that was previously unknown has traveled in front of the star and therefore blocked it off. So where's this all going in the future? I'm certainly hoping for TARDIS, but realistically, the next stage is to kind of get users controlling their own spacecraft and making it a lot more interactive. So thank you very much.